In this video, we will talk about the future of space exploration, Mars missions. Space exploration has captivated humanity's imagination for centuries, fueling a quest to understand our place in the universe. With advancements in technology, Mars has emerged as a primary focus for exploration due to its proximity to Earth and features that suggest it may have once supported life. Mars, often called the Red Planet, is considered the next frontier in our journey beyond Earth, especially as scientists and visionaries contemplate the possibility of human settlement there. This essay explores Mars missions, their achievements, and the challenges and potential solutions for future exploration, emphasizing the dream of making humanity a multi-planetary species. 1. Background: Mars and its characteristics. Mars is the fourth planet from the Sun, known for its dusty, red surface and unique features that set it apart from Earth. With vast deserts, polar ice caps, towering volcanoes like Olympus Mons, and canyons such as Valles Marineris, Mars presents an intriguing yet hostile landscape. The thin atmosphere, composed mostly of carbon dioxide, lacks the warmth-trapping effect that keeps Earth habitable, leading to cold temperatures and extreme daily swings. Dust storms often engulf the planet, creating challenging conditions for rovers and landers. Mars has long fascinated scientists due to these similarities and contrasts with Earth, inspiring decades of telescopic studies and space missions to unlock its mysteries. 2. Why explore Mars? Mars exploration serves multiple scientific, practical, and philosophical purposes. From a scientific standpoint, Mars offers clues to the formation of terrestrial planets and helps us understand planetary evolution. One of the most compelling motivations is the search for life. Evidence of ancient water sources, such as riverbeds and polar ice caps, raises the possibility that Mars may have harbored microbial life in the past. Mars also presents an opportunity for human expansion, with its resources and proximity making it a potential candidate for future human colonies. Exploring Mars could therefore provide insights into sustaining life beyond Earth and preparing for potential human settlement on other planets. 3. Major Mars missions to date. Several landmark missions have shaped our understanding of Mars. Early missions, like NASA's Mariner and Viking programs in the 1960s and 1970s, provided the first close-up images and data on the Martian surface. In the 2000s, NASA's rovers Spirit and Opportunity revolutionized Mars exploration by uncovering strong evidence of past water activity. The Curiosity rover, which landed in 2012, continued these efforts, analyzing rocks and soil to understand Mars' ancient environment. More recently, the Perseverance rover, along with international missions like China's Tianwen-1 and the UAE's Hope probe, aims to collect rock samples, study the Martian atmosphere, and explore possibilities for future human missions. These missions have paved the way for the next phase of Mars exploration. 4. Key objectives of future Mars missions. The objectives of future Mars missions are broad, focusing on both scientific discovery and preparing for human arrival. A primary goal remains the search for signs of life, past or present. By studying soil and rock samples and analyzing Martian environments, scientists hope to find evidence that life may have existed on Mars. Future missions also aim to assess the availability of resources like water and minerals, which are crucial for supporting human life on Mars. Technology development is another key objective, as future missions will test new landing systems, energy solutions, and robotic tools necessary for long-term exploration. 5. Human missions to Mars, the next frontier. Human missions to Mars represent the next big leap in space exploration. NASA's Artemis program, which focuses on returning humans to the Moon, is seen as a stepping stone to future Mars missions, helping develop skills and technologies needed for longer journeys. Plans for human settlements on Mars, including potential cities or scientific bases, are becoming more tangible with the advancement of technology. Companies like SpaceX, led by Elon Musk, are at the forefront of Mars colonization ambitions, aiming to use reusable rockets like the Starship to transport people to Mars. The idea of creating sustainable habitats on Mars, where humans could live and work, marks an exciting future for interplanetary exploration. 6. Technological challenges of Mars missions. Missions to Mars face several unique technological challenges. The distance from Earth creates a significant delay in communications, making it difficult to operate systems in real time. The harsh environment on Mars, including extreme cold, high radiation levels, and dust storms, poses additional risks to equipment and human health. Landing safely on Mars is a complex process, requiring precise navigation and robust technology to withstand the planet's thin atmosphere and rough terrain. Return missions for human crews would also face significant challenges, as they would require safe re-entry technology and potentially months or years of life support systems. 7. Potential solutions and innovations. To overcome these challenges, scientists and engineers are developing innovative solutions. Nuclear and solar power systems are being designed to power rovers, habitats, and equipment on Mars, where sunlight is weaker than on Earth. New 3D printing technology could allow astronauts to build shelters and structures on Mars using Martian soil, reducing the need to transport building materials. Life support systems that recycle air, purify water, and enable food growth are being researched to sustain human crews on long missions. These innovations represent important steps toward making Mars missions safer and more sustainable. 8. Ethical considerations and planetary protection. Mars missions also raise ethical questions about our responsibilities toward other planets. One concern is planetary protection, ensuring that Mars is not contaminated by Earth microbes that could interfere with the search for native life. Scientists are developing strict sterilization protocols to prevent contamination. Additionally, as discussions about potential human settlements advance, questions arise about preserving Mars' natural state versus transforming it for human use. Ethical considerations thus play a crucial role in guiding Mars exploration, balancing scientific goals with respect for the unknown. 9. International collaboration and the future of Mars exploration. The future of Mars exploration will likely involve collaboration between nations and private companies. Space agencies from around the world, such as NASA ESA, Roscosmos, CNSA, and JXA, have shown an interest in Mars, and their combined expertise could accelerate progress. Collaborations reduce costs, share risks, and bring together diverse expertise, fostering a global approach to space exploration. Private companies like SpaceX and Blue Origin are also playing an essential role, bringing innovative ideas and funding. Together, these partnerships are expected to drive Mars exploration forward, making the dream of reaching and possibly settling Mars more achievable. Mars missions represent a remarkable chapter in human exploration, driven by curiosity, scientific interest, and the possibility of future colonization. As technology advances and collaborations grow, Mars may be within reach for human explorers in the coming decades. While significant challenges remain, from technical hurdles to ethical concerns, each mission brings us closer to understanding Mars and possibly establishing a human presence there. The future of Mars exploration is filled with potential, promising new discoveries that could expand our knowledge and perhaps one day allow humans to call Mars a second home. What do you think of our video? Let me know in the comment section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go. Thank you for watching.